Hello, and welcome to this section on threading. In this video, we will be introducing you to the concept of threads. All of the programs we have written so far have been single-threaded programs. Single-threaded software is very easy to write and understand since each line of code executes sequentially, blocking the execution of the next line until it is complete. However, some software cannot be written in this way, and it has to do more than one thing at a time. For example, when writing a web server, you want to be able to handle more than one user at a time. In order to do that, you have to accept the connection from the user and then pass that connection to something else to continue the function. Doing this allows your software to wait for another connection while servicing the first one, and it will handle multiple clients simultaneously. There are three, main ways to accomplish the something else part of this program. You could spawn a process. This was the old way to do things, but it had some drawbacks and some overhead. You could spawn threads, which is what we'll be learning about, or you can use an evented I/O model like Node.js, but we won't be covering that here. Processes and threads are a lot alike with one major key difference. Threads share memory and processes do not, and we will learn more about this later in the section. Here we can see how different processes are running. The first is a classic single-threaded process. It just runs continuously until it is finished. The second example is a multi-threaded process that is running on a single core CPU. The threads are time-sliced and interleaved, making it appear as though more than one thing is being done at the same time. Keep in mind that the OS also interleaves your whole process with other processes running on the same computer. This is why you can surf the web and program and listen to music all at the same time. Finally, the third process that's running is on a multi-core system, so the two threads are actually running simultaneously. So how do we write multi-threaded software? In the dark ages, before C++11, you would need to use OS-specific libraries in order to use threading. Windows.h Win32 threading on Windows, and pthread.h POSIX threads on Unix and Linux systems. This caused any software to be non-portable, which means you had to do a lot of work using include guards and preprocessor code to make it portable. But now, in the golden age of C++11 and beyond, we can now use the standard library threading features to write multi-threaded software and not worry about the underlying OS it's written for. The C++ standard template library gives us everything we need to create threads, locks, condition variables, and mutexes. It also provides atomic values and some async functionality. These are the headers that we will be including to use the different threading facilities. Thread is the most important one because it actually defines the thread that will be launched. Mutex defines the mutual exclusion objects and locks. Future defines the async promise and future objects. Atomic defines the atomic values, and condition variable defines the condition variables we will use to signal between threads. We will be covering all of this in this section.